Okay, let's practice finding the maximum and minimum of the function f of x equal to x squared minus 10x. So in this problem, we're going to be doing the problem 3 times, one time with the interval 0, 6, then 4 to 6, and then the negative infinity to positive infinity. So the first two parts are going to be closed intervals. So closed interval. That's because of the bracket on 0, bracket on 6, and again it's going to be a closed interval on 4 to 10, and the final one is going to be an open interval. So we'll see the difference between each one of those and how to do the math for each one of them. So I'm going to start by looking for the derivative, so let me do that real quick over here. So the f prime of x is going to be, let's do 2x minus 10 first, and what makes it 0, it's going to be 5. So the critical number is going to be 5 only. Okay. Now for the first part, it says the interval is between 0 and 6. So let's make a table. Because it's a closed interval, it's easier to decide with a table. And remember, we're going to be putting x squared minus 10x into the calculator. Okay. So the table is going to have the 0, the 5, and the 6. So why 0? 0 because that was the start of the interval. Why 5? 5 because that was the critical number. And why 6? 6 because that was the end of the interval. So that's what we do with all the problems where we have a closed interval. So let's punch this into the calculator and see what we get. So did you get 0, negative 25, and negative 24? I hope you did. So now, once you have this done, you're going to be able to decide who's going to be the max and who's going to be the minimum. So remember, the highest y, the biggest y is going to be the max. Out of these three numbers, this one has the biggest number, so it's going to be the max, and actually it's going to be called an absolute max because, you know, it's the biggest number. The one with the smallest value is going to be negative 25, so this one is going to be called the minimum. So the minimum happens at 5, and the value of it is negative 25. That's how we call these things usually. You know what? Let me make this a little bit bigger, and that's basically the end of the problem. Okay. Now, what about if the interval was 4 to 10? I don't have to do any of the work all over. I just have to copy paste some of the stuff. So let me do that. Okay, so here the critical numbers are, well, first of all, 4 is going to be the starting point. So we're going to put 4 in the table. The critical number was 5. So we're going to be putting 5 in the table. And the last number is 10. So again, 5 because it was a critical number, and 10 because it was the end of the interval. And again, put this in your calculator and get the values of the function. So I'll give you a second to think about that. So did you get negative 24, negative 25, and 0? And again, depending on the interval, your max and your min is going to change. So on this interval, the highest number, the biggest y coordinate is this one. So that's going to be the maximum, and it's going to be the absolute maximum so far. And the minimum is going to be the one with the 5 and negative 25. This is going to be the minimum, and as a matter of fact, this is going to be the absolute minimum. So let's pause here for a second and kind of think about what just happened. So at the first, in the first problem at 0, we started from 0, we ended at 6. The graph kind of did this. It went from being high to being very low to being kind of like lowish at the end. Like it's not too low at the end, but it kind of did this kind of thing. So it was the lowest right here at 5, and at the 0 it was the highest. That's kind of what we saw in the first picture. So let me keep that here on the side. And what about the second interval? So the second interval went from 4 at the start to 10 at the end, and it kind of went from being kind of very low to being more low at the 0.5, and then it went back up high. So if we put these two pictures together, it seems like the graph is doing this, and then one time we're looking at it from the start to here, then one time we're looking at it from here to there, basically. So obviously the graph is gonna have different maxes and different mins depending on the interval. So this is not required really, but that's just for understanding. Now let's look at the last part and see what's going on there. Okay, so for the last part, the interval is open. So whenever there's no interval mentioned or the interval is negative infinity, positive infinity, we pretend like that's an open interval. So to decide the max and min, we have to do the same usual thing and run the first derivative test. So I'm starting with negative infinity, positive infinity, and 5 is in the middle. Pick a number before to test, let's say 0. Pick a number after to test, and we're going to put these numbers into the derivative. So when 0 goes into the derivative, we end up with negative 10. So the answer is going to be negative, which means the function is going to be going down. And when 10 goes into the derivative, we get positive at the end, which means the function is going to be going up. So, fx is going up. So what does that mean about the number 5? The number 5 is going to be, in this case, what we call a minimum. So this is a minimum. Now on this graph, 5 was the only critical number. So according to what we just learned, this is going to be what we call an absolute minimum, because it is the only minimum on the whole graph. So did that make sense or no? Let me know. Also, it is important to notice that the last part has no maximum, right? So there's no maximum because my graph is on an open interval. Remember, the extreme value theorem says if you're on a closed interval, you're guaranteed a max and a min. If you're on a closed interval, you're guaranteed a max and a min. But if you're on an open interval, there are no guarantees. Anything could happen, and it turns out that in this particular example, the open interval result gives us basically no maximum.